Okay, welcome to the lesson on graphing inequalities. We're going to be graphing inequalities on a coordinate plane using two variables, x and y. So far we've graphed linear equations. We're going to take the next step today, and we're going to graph linear inequalities on a coordinate plane using x and y. And so you can see the standards we're going to be looking at. We're going to be understanding the word constraints that happen in an inequality. Constraints just means what answers make sense and what answers don't in the particular context of a problem. Okay, we're also going to be graphing solutions to a linear inequality in two variables as a half plane of a graph. We're not going to be looking at a solution to systems today, but just single inequalities. So far we've graphed linear equations before, x and y, on a coordinate plane. Today what we're going to look at is how to graph linear equations and how do we solve these inequalities, graph linear inequalities and solve them by graphing. So we've got some new vocabulary that we're going to look at. And we're going to take a minute to go through each of these terms, make sure, because it's important to understand what each of these things means. So the first thing, the boundary. Okay, in an inequality, just like in an equation. So when we solve an equation, we get a solution that is true, that works for that particular equation. In an inequality, we're looking for the solutions that make the inequality true. So what that means is that we get an infinite number of values that will make an inequality true. If I say all the numbers that are less than 2, you could give me an infinite number of values that are less than 2. If I say x is greater than 2, you can give me an infinite number of values that are greater than 2. So what we're going to do is we're going to graph these inequalities, and instead of having to list out every single possible combination of values that makes it true, we're just going to create a graph to visualize what that would look like. Right, so the graph is made up of several different things. First, it's made up of a boundary line. So on a graph, the boundary line is what separates the true side of the graph from the false side of the graph. So for our particular inequality, one half of the graph would be true, the other half would be false, and the line between those two is the boundary. Okay? The boundary is what splits the graph into two what are called half planes, okay? Which makes sense. We split a graph in half the plane is true, the other half is false. So the boundary splits the graph into two half planes. Then we're going to look at two different types of graphs, one with a closed half plane and one with an open half plane. So a closed half plane is a graph that has a boundary line that is included in the solution. So the boundary line is actually going to be a solid line because all of the values on that line are included in the solution. An open half plane includes a boundary line, but the boundary line is a dotted line. And because the dotted line or the dotted boundary is not included in the solution to the inequality that we solve. And you'll be able to see this as we go through. So the main takeaways are that the boundary is the line that separates the half plane, the two half planes, from solutions that are true and solutions that are false. And we have two different types, a closed and an open. A closed boundary or a closed half plane includes the boundary line as a solution. The open half plane does not include the boundary as a solution. So first let's talk about how we graph linear equations, because this plays a huge role in how we're going to graph linear inequalities. If we don't know how to graph linear equations, we won't be able to graph linear inequalities. So just a quick review. When we solve linear equations and we want to graph them, to graph it we have to put the equation into what is called slope-intercept form. So that's y equals mx plus b. M is the rate of change or the slope, b is the y-intercept. So again, the b value is the y-intercept. That's where we start our graph. Okay? It's on the y-axis. We look for this point, that's where we start our graph. And then the m value, whatever it is being multiplied by x, is the slope or the rate of change. That lets us find other points along the line that we have. So we have two things to graph a straight line. We need a starting point and we need a pattern or the rate of change. Okay, so that's our m and our b values. So we rewrite any equation that we have into this form and we're able to create a graph based on that equation. So let's take a quick review and we're going to graph a equation to see what, just to make sure we can remember how to do it. All right, so graph the equation y equals 2x plus 3. All right, so the first thing that I notice is that this inequality, or sorry, this equation, y equals 2x plus 3, is already in y equals mx plus b form. Right? It's already in the form that I need it to be in, so I don't need to rearrange it at all. I can already see what my values are. Okay? And in this case, I'm looking for two particular things. I'm looking for what is being multiplied by x, that's my m value. I'm looking for what is added at the end, that's my b value. Okay? So in this case, m is 2 and b is 3. So if I want to graph this equation, right, I'm going to create a graph, just a quick sketch. So we've got our x and our y axis, and this isn't going to be perfectly straight, but it'll be close. Right? So remember, just to review, x-axis goes side to side, y-axis goes up and down. Okay. So the first thing I need to do is I need to start with my first point. So let's put some dashes on the line. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I need to put my y-intercept on the graph as my starting point for the rest of my line. So this particular y-intercept is at 3. That means my starting point is where y is 3. So on the y-axis, I go up to 3 and I put a point. Okay, that's my starting point for this graph, where y is 3. Now, the slope is 2. And if you remember, slope is the change in the y value over the change in x. So ideally, I want to write slope as a fraction. So it's 2 as a fraction is 2 over 1. So the rate of change, the line is changing by 2 on the y-axis for every 1 on the x-axis. So that means I'm moving up 2 on the graph every time I move over 1 on y. So if I'm at 0, my graph is at 3, my starting point. So if I move over 1 x value, my y value increases by 2. So if I go over to 1 on x, I go up from 3, I add 2 to 5 on my y-axis. If I move over another 1 on x, I move up 2 more on y. So I've got those points there. All right, and then all of the points along this line, they'll make a completely straight line. And any point on that line is a solution to y equals 2x plus 3. So I take those points and I just connect them with a relatively straight line. Okay. So this line is all of the solutions to y is equal to 2x plus 3. And we got that again by identifying the y-intercept, 3, and then using the slope to find the other values on that line. So I started at 3, my slope is up 2 and over 1, so I go up 2 on the y-axis as I move over 1 on the x-axis, up 2 over 1. And I would keep going in that pattern forever along that line. So that's just a quick review. How do we graph linear equations? Because we need to know how to graph equations in order to graph inequalities for x and y variables. So some key points to graphing linear inequalities. Step 1, we have to graph the boundary line. So because we're graphing a line, we're going to be writing an equation in slope-intercept form, because that boundary will tell me how the graph is split into two different parts, the true and the false side. Okay. We use a solid boundary line if the inequality is less than or equal to or greater than or equal to. We use a dashed line or a dotted line when the inequality contains just less than or greater than. Right? And the reason we use a solid line for less than or equal to or greater than or equal to is that because the values along that boundary line in these two situations also make the inequality true. Okay? We use a dotted line for just less than or greater than because the values along that line are not included in the solution. Okay. So when we make the boundary line, we're going to use either a dotted line or a solid line, depending on the type of inequality that we're looking at. Right, so once we have our boundary line, we need to test and see which side of the half plane is true. And the side that is true, we shade it to represent the solutions. So we use a test point on either side of the half plane, decide which side is true, and then shade the half plane that contains the solution to the inequality that we're solving. So let's start at the beginning. 2y minus 4x is greater than 6. So if I've got this inequality, I want to graph all of the possible solutions for x and y that make this inequality true. So step one is to rewrite the equation so that just like with our equations, we want it to be, let me use a different color. We want to use y and mx plus b. All right. Now, the only difference is that instead of using y equals, we're still going to use y equals because we're graphing a line, but our inequality is going to follow us throughout the problem. But we need to make this line y equals mx plus b in order to find the boundary. Okay. So that's what it means by solve for y in terms of x. They want you to rewrite this inequality so that it's y equals mx plus b. So write the original inequality, 2y minus 4x is greater than 6. And then we're going to add 4x to both sides because we need to take everything away from here except y. We need to move everything to the other side. So the first step is to, if I'm got 2y and I'm taking 4x away, I need to add it back. And if I add 4x to one side, I have to add 4x to the other side. So 2y minus 4x plus 4x, those two cancel each other out. And so we're left with 2y is greater than 4x plus 6. So now, just like when we were solving equations, we're going to solve for y by dividing by the coefficient. That's the number that's being multiplied by y. So 2 times y is greater than 4x plus 6. I'm going to take 2y and I'm going to divide it by 2. And if I divide 2y by 2, I need to divide everything on this side, 4x plus 6, by 2 also. So that's what we see here. 2y divided by 2 is greater than 4x plus 6 divided by 2. So now, at this point, what we're going to do, 2y divided by 2, the 2's cancel out, right? And on this side, we're actually going to divide each part here by 2. So we're going to take 4x and divide it by 2, and 6 divided by 2. And that gives me y is greater than 4x divided by 2 is 2x, 6 divided by 2 is 3. So my inequality is that y is greater than 2x plus 3. So we started with 2y minus 4x is greater than 6, and we solved the equation. We rearranged it so that it was in y equals mx plus b form. So that's what we've got here. Y is greater than 2x plus 6, or sorry, 2x plus 3. And so if you notice, we can analyze this inequality the same way that we analyzed the equations before. I have a y-intercept and I have a slope, which will allow me to graph the boundary line for this particular inequality. So we're going to graph y equals 2x plus 3 to get my boundary line. Okay. And so what we've got here is the line for y is greater than, or y equals 2x plus 3. So notice this was, again, m is 2 because it's mx plus b, and b is 3. So my starting point on my graph is at 3. I can use a different color. So my starting point is 3 on my y-axis. Okay. And then I use my slope 2 to find the other points on my line. So if my slope is 2, that means my y value is changing by 2 every time I change x. So I go up 2 as I move over to the next x value. Right. So if I was 0 and 3, at 1 it's going up to 5. If x is 2, y is 2 more up, so that's up at 7. All right. And notice we could go backwards too. If we started at 3, when x is 0, if I move back 1, I need to take away 2. So I'm down here. If I move another one, I'm taking away another 2. So the point is down here. Okay, so we can go both ways on the line. Either way, what you notice is that all those points are all on the same line. Now, look at the line that they drew. The line that they drew is a dotted line, right? That's because y is greater than 2x plus 3 does not include any values where y is equal to 2x plus 3. So we use a dotted line because this is just greater than. Okay? We're looking for all the places where it's greater than, not equal to 2x plus 3. So now what we need to do is test which side of the graph is going to be true and which side is going to be false. The easiest point to use is 0, 0. All right, so if 0, 0 is not on the line that you've graphed, I would recommend using 0, 0 as a test point because that's the easiest one to solve. So what do? We take the inequality that we have, y is greater than 2x plus 3, and we replace x and y with our test point, 0, 0. And so if x is 0 and y is 0, we replace x and y. 0 is greater than 2 times 0 plus 3. 2 times 0 is 0. 0 plus 3 is 3. So the inequality that I get is 0 is greater than 3. Now, is that true? No, it's false, which means that 0, 0, it does not make the inequality true. So we picked 0, 0 on this half of the line, okay, but it wasn't true, which means that if this side is not true, all of my possible values then that are true for this inequality must be on the other side of my graph. So I kind of shade in this side of the graph because the side with 0, 0 wasn't true, which means everything on the other side of the line should be true for our particular inequality here. Again, since the statement was false, the half plane containing the origin, or 0, 0, is not a part of the solution. We shade in the other half of the half plane because that's where all of these values make the inequality true. And we can test, if we choose a point on this side of the line, it should give me a true inequality. Okay? If it doesn't, if both sides are false, that means I've made a mistake somewhere. Either my line's incorrect or I made a mistake in the arithmetic, something along those lines. So I want to double check just to make sure that there's a point, the point that I choose on this side is actually true. So we're going to choose -3, +1, which is, as you can see, -1, 2, 3, +1 right here. Okay. So if we use that point, it should give us a true statement. So again, we use our inequality. Y is greater than 2x plus 3. But now x is -3 and y is +1. So 1 is greater than 2 times -3 plus 3. 2 times -3 is -6. -6 plus 3 is -3. So is 1 greater than -3? Yes, it is. So this side is in fact true. So everything on this side of the boundary line is a solution to our original inequality. Okay. So that means this graph is correct. We've correctly done it. We took the inequality, we created the boundary line using y equals mx plus b, slope-intercept form, and then we tested points on either side of the boundary to see which was true and which was false. 0, 0 was false, -3, 1 was true, which means everything on this side of the boundary line is a possible answer to our inequality. Okay, so why don't you take a minute and graph y minus 3x is less than 2 and shade in the correct side of the half plane to demonstrate what is the solution to the inequality listed here. Okay, so the correct answer was A, and I'm just going to quickly go through and show you how we got A. So if we start with our inequality, y minus 3x is less than 2. The first thing we need to do is rewrite it so that it's y equals mx plus b, because that allows me to graph my boundary line. And so I've got y minus 3x is less than 2. The first thing I need to do is move all of the x values to the other side. less than 2. So the first thing I need to do is, if I'm subtracting 3x from here, I need to add 3x to both sides. Add 3x. So that gives me y is less than 3x plus 2. And now I'm in the correct form. Y equals mx plus b, y equals 3x plus 2. So to graph this inequality, m is 3, my slope is 3, or 3 over 1. And my starting point, or my y-intercept, is 2. So when I graph this inequality, I want to write a boundary line where the y-intercept is 2 and it has a slope of 3. So what you notice is that each of these 4 options here are all the same line. They're all starting at 1, 2, 0, 2, 2, 2, and 2. And they all have a slope of 3 over 1. So at y goes up 3 and over 1. The slope goes up 3 and over 1. Up 3 over 1, up 3 over 1. So they all have the same slope, they're all the same line. What makes them different? Well, B and D here are solid lines. A and C are dotted lines. So remember, when we want to graph an inequality, if the inequality is greater than or less than, we're using a dotted line because the boundary line is not included in my solution. So that eliminates B and D because those are solid lines. So my solution is going to be either A or C. And what's different between them? Well, just the side of the graph that is shaded in. Right? So notice the line doesn't go through 0, so I can use 0, 0 as a test point. Okay, so I'm going to take 0, 0, and I'm going to test it to see if it's true or not. So remember, my inequality is y is less than 3x plus 2. Right? If I replace x and y with 0, what do I get? So 0 is less than 3 times 0 plus 2. 0 is less than 3 times 0 is 0, and 0 plus 2 is 2. Is this true? Is 0 less than 2? Yes, it is. So that means the side of my graph where 0, 0 is the true side of the graph. So between A and C, A shows the half plane with 0, 0 shaded in. So it's saying that this side of the graph is true, which means A is the correct answer to this inequality here. Y minus 3x is less than 2 would be graphed like that. All right, now we're going to do the same thing, but we're going to be graphing greater than or equal to or less than or equal to. So our process is the same. The only difference here is that our inequality is now or equal to. Right? So it's greater than or equal to or less than or equal to. And what that does is it just changes my boundary line from a dotted line to a solid line. So if we want to graph x plus 4y is greater than or equal to 2, first thing we need to do is rewrite the equation so that it's y equals mx plus b. So we start with x plus 4y is greater than or equal to 2. And this first step is to move the x to the opposite side. So I take away x here, and I take away x here. So that leaves me 4y is greater than or equal to negative x plus 2. Then we're going to divide both sides, everything on both sides by 4. So we do 4y divided by 4, negative x divided by 4, and 2 divided by 4. All right, and that gives me, so 4 divided by 4 is 1. Negative x over 4. Remember, if I don't have a number in front of the x here, that means there's a 1. All right, so it's actually negative 1 over 4 times x. And 2/4 just simplifies to 1/2. So my inequality is that y is greater than or equal to negative 1/4 plus x. Right. So what we want to do is graph y is greater than or equal to negative 1/4 x plus 1/2. And because the inequality symbol is greater than or equal to, the line that I make is going to be a solid line. So let's take a look at the graph down here. They've already graphed it for us. But let's just go over it. So my y-intercept, if I'm looking at my slope-intercept form, m is negative 1/4, b is 1/2. So that means my graph starts at 1/2 here. And then notice my slope is negative, so my line should be going down. And my change is that I'm going down 1 on the y-axis. Every 4 I move on the x-axis. So to move negative 1/4, I start at 1/2 and I go down 1, which would put me down here. Right? And from there I count over 4. 1, 2, 3, 4. Okay. I could go the opposite way. If I went up 1, then I would go to the left 4. 1, 2, 3, 4. Okay. And then I connect those points in a straight line. So this graph, this line here, shows me that y is negative 1/4 x plus 1/2, and we use, again, a solid line because the inequality is greater than or equal to. All right, so now what we want to do is test a point. Again, we could use 0, 0. In this case, we're going to use something different. We're going to use 2, 2, just to show you one particular trick here. So if you notice the inequality that we got here, y is greater than or equal to negative 1/4 x plus 1/2. There's a lot of fractions involved in this inequality here. So what we could do instead of having to use this inequality that we found, we could use the original inequality that we started with. Right? We can use x plus 4y is greater than or equal to 2. This inequality and this one that we got here, y is greater than or equal to negative 1/4 x plus 1/2, are the same inequality, just written 2 different ways. Right? So I can use this, or I can use my original. My original doesn't include any fractions, which makes it easier for me. So I'm going to use the original inequality, and I'm going to replace x with 2 and y with 2. So 2 plus 4 times 2 is greater than or equal to 2. Well, 4 times 2 is 8. 8 plus 2 is 10. 10 is greater than or equal to 2, which is true, which means the side of the graph containing 2, 2 must be where my true solutions are, so I shade in that half of the graph. Okay. So again, we made the boundary line in y equals mx plus b form, chosen any point to test the inequality. And in this case, we used our original inequality because it was easier for us than using the fractions from slope-intercept form. And we found that 2, 2 was a solution. It made a true statement, so that half of the graph got shaded in because all the values on that side of the boundary line are true. All right, so we're going to take a minute to graph x plus 2y is greater than or equal to 6. And the correct solution was A. So again, I can walk you through it really quickly here. If we take our inequality, x plus 2y is greater than or equal to 6, the first thing we need to do is rewrite it so that it's y equals everything else, right? Or y, in this case, is greater than or equal to everything else. So if I take x plus 2y is greater than or equal to 6, right, the first step is to move x to the opposite side. So I'm going to take x and I'm going to subtract it from both sides. Take the x away. Right, so that's going to leave me with 2y is greater than or equal to negative x plus 6. And now I need to get rid of the 2 that's here. So I take 2y and I divide it by 2. I take negative x and I divide it by 2. I take 6 and I divide by 2. And that leaves me with the equation y, or the inequality, sorry, y is greater than or equal to negative 1/2 x plus 3. Negative x over 2 is negative 1x over 2, or 1/2 x. 6 divided by 2 is 3. Right, so this is my inequality. Y is greater than or equal to negative 1/2 x plus 3. And again, just like before, technically the 4 lines that they give me here, these 4 graphs are all the same line. So I just need to determine which ones I can eliminate. Since I'm dealing with greater than or equal to, I know my line, my boundary line is going to be solid. So that leaves me A and B. C and D are dotted lines, so I know those won't work. These are the same equation, or sorry, these are the same lines. They both have a y-intercept of 3 and a slope of negative 1/2, moving down 1 and over 2, down 1 over 2. So then I just need to determine which half of the graph is true. So again, I like to make it easy on myself, and I'm going to test with 0, 0. And again, because our inequality here includes a fraction, I don't have to use it. I can use my original one. X plus 2y is greater than or equal to 6. So if I take x plus 2y is greater than or equal to 6, and I replace x and y with zeros, what do I get? All right. So I take x is 0 plus 2 times 0. Well, that makes everything over here 0, right? Is that greater than or equal to 6? Well, 0 is greater than or equal to 6. Nope, that's not true. Okay. So 0 is not greater than or equal to 6, which means that 0, 0 is not a part of my solution, so I shade in the side that does not have 0, 0. So between A and B, A shows the side that has 0, 0 not shaded in. It's the opposite side of the boundary line, so that's how we get A as a solution to x plus 2y is greater than or equal to 6. Okay, let's take a look at this type of inequality really quickly. Use a graph to solve 2x plus 3 is less than or equal to 7. First thing that you notice here, there's no y value in this inequality. There's just an x value. Now that doesn't mean that we can't solve it. It just means that we're not going to be able to write this in y equals mx plus b form. Right? So instead of doing it that way, since there's only one variable, the easiest way to solve for this is to just solve for x. Right, so we're going to solve the inequality for x. We're going to start with 2x plus 3 is less than or equal to 7, and we're going to see what are the values of x that make that true. So my first step is to take away this 3. 2x plus 3, I need to take the 3 away. So I subtract 3 from both sides. So that leaves me with 2x is less than or equal to 4. Right. Then I need to know what x is, so I'm going to take 2x and I divide both sides by 2, which cancels that. So we're left with x is less than or equal to 4 divided by 2 is just 2. So my solution is that x is less than or equal to 2. All right, so what we're going to do is we're going to graph a line where x is less than or equal to 2. We're going to use a solid line because it's less than or equal to. And I'm looking on my graph for all of the locations on the graph where x is less than or equal to 2. So just like when we did y equals mx plus b, we graphed the straight line. Well here, x is 2 at this point here. That's where x is 2. X is also 2 up here at this point, and this point, and this point. Basically, I could continue going up or down this particular line here. X would always be 2. That's what I'm looking for. If I move left or right, x is no longer 2. So that's why I draw the line going straight up and down where x is 2. Now we're going to graph the side of the line where x is less than or equal to 2. Well, where is x less than or equal to 2? It's everything on this side of the graph. x is less than or equal to 2 for everything to the left of the line that we created. So we shaded in this side of the line of the graph. Right? So we could still solve it even though we didn't have a y value in that inequality, we were still able to graph this solution. Right? So why don't you give it a shot? 5x minus 3 is greater than 17. Which of these solutions, A, B, C, or D, matches the graph that you get with the solution? And the correct answer is 4. X is greater than 4. So we made the dotted line because it was just greater than, it wasn't equal to, so the dotted line goes at 4, and then X was everything above that. So we shaded this half of the graph where X was more than 4. So if I look at my problem, I have two variables, two things that I'm trying to measure. Right? We're looking at how long it takes him to write an article and how long it takes him to edit an article. So we have two different things that we're measuring, the articles that he writes and the articles that he edits. Because we have two different things, we need two different variables. They can't be using the same thing. So what we want to do is let x be equal to the number of articles that Ron John can write and y be the number of articles that Ron John can edit. All right, so what we're going to do is take that situation and write it using an inequality. So it'll look something like this. The number of articles that Ron John can write is x. All right, so each hour Ron John writes one article. So in 2 hours it would be 2 articles, 3 hours, 3 articles, and so on. And so any number of articles that he can write in an hour is x, plus the half hour that it takes him to edit an article. So we do 1/2 times y, the number of articles that he can edit. So our inequality, or the total amount that he can get done, is x, the number of articles he can write, plus 1/2 times y, the number of articles he can edit, and together, right, that number of hours is going to be less than or equal to 8 because he's not going past 8 hours of work. So we're going to solve the inequality in terms of x. So we start with the inequality, x plus 1/2 y is less than or equal to 8. Subtract x from both sides. And so x minus x cancels out. I've got negative x plus 8 on the other side. So I've got 1/2 y is less than or equal to negative x plus 8. Now, if you remember back before, what we said was that when we're dividing by the coefficient of y, right, we could say we're dividing everything here by 1/2. But again, what happens when we divide by a fraction? We keep it, change it, and flip it. So instead of dividing by 1/2, I'm actually going to multiply by the reciprocal. So if I take 1/2 and I multiply and flip 1/2, I'm actually multiplying by 2 over 1. So I multiply by 2 over 1 on that side, and then I multiply this whole side also by 2. And that's what we see here. So we multiply 1/2 times 2, which will cancel out. Multiply 2 times negative x plus 8. And that leaves me with the inequality. Y is less than or equal to, do the distributive property, 2 times negative x is negative 2x. 2 times 8 is 16. So my inequality is y is less than or equal to negative 2x plus 16. All right, so now how do we graph this? So we're going to use y equals mx plus b. My starting point is 16. So up on the y-axis, I start with 16 with my point. My slope is negative 2, meaning every time I move over 1 on x, I move down 2 on y. So if I'm at 0 and I move over 1, I'm going to go from 16 down to 14. I go down 2 as I go over 1. To get the next one, I move over another 1. I move down 2 more. So 2 is now down to 12. 3 is down at 10. 4 is at 8. 5, 6, 6, 4, and so on. All the way down to where it's 0 at 8. Okay. Now what I want to do is use a test point. Again, we can use 0, 0. If I plug in 0 to my to my inequality here. 0 is less than or equal to negative 2 times 0 plus 16. Right? Well, that's going to be a true statement because 0 is going to be less than 0 plus 16, which means everything on this side of my graph is included in my solution. All right. Now, let's analyze the way that they did this graph here. If you notice, they didn't shade anything over here or down here or down here. They didn't even extend the line past 8 or 16. And why is that? Well, let's think about what the problem was talking about. The problem was talking about the number of articles that Ranjan could write and edit. Right? So X was the number of articles that he could write. We don't go past 0 on X because Ranjan can't write a negative number of articles. So there's no point in including those values because they don't make sense in this problem. Right? This is what's called a constraint on the situation. There's a limit to the values that make sense. Right? Negative numbers don't make sense for the number of articles he can write. Same thing, negative numbers don't make sense for the number of articles he can edit. Remember, that was my Y value. So he's not going to edit a negative number of articles either. So we're only going to include positive values in our solution to our inequality. That's why we don't shade anything beyond the negative values either. We're only shading positive values. Right? Another way to look at this graph is, what do these 0 points tell us? Well, remember, X was the number of articles that he could write. Right? Remember, if he's not working more than 8 hours and it takes him an hour to write an article, the most that he can do in one day, in 8 hours, is write 8 articles. If he writes 8 articles, he doesn't have time to edit any, so he's at 0 edited articles. Right? He could also write 6, 4, 2, 5, 3, 1, or 0. If he writes 0 articles, that means he has enough time to edit 16 articles, because remember, each one of those only takes him half an hour. Okay. So looking at this graph, it fits in with the information that we're given. Now notice all these values in between here. He doesn't have to work a full 8 hours. He could write 2 articles and edit 2 articles. He could get that done in 8 hours, so that's why that area is shaded in. He could work for write 4 articles and edit 6 articles in his 8-hour time limit. Right? If he writes 4 articles, the most articles that he can edit is 8. He can't edit 10 because he runs out of time. Notice anything on this side of the line doesn't work. If he writes 6 articles, he can't also edit 6 articles. Right? If he writes 6 articles, he can't also edit 12. If he edits 12 articles, he can't write 4 because it's outside of our boundary line. So this graph tells us a lot of information of what Ranjan can get done in a certain amount of time in his 8-hour day. It's all the possible combinations of articles that he can write or edit in a single 8-hour day. Right. So again, this kind of summarizes what we just talked about. He can't work a negative number of hours, so the domain and range contain only non-negative numbers. He can't write or edit a negative number of articles. Ranjan's only going to count whole numbers, right? He's not going to count part of articles that he writes or edits, so we're only going to use whole numbers as our solution. One possible solution is 2, 3, which means that he could write 2 articles and edit 3. All right. So go ahead and read the problem here, answer the question, how many sandwiches could you purchase for $30? So what is a possible combination of chicken sandwiches and tuna sandwiches that you could buy for $30? All right. A, B, C, or D. What is a possible combination that you could get for $30 if $30 is the most that you could spend? And the correct answer is D. D is the only possible combination. 5 chicken sandwiches and 9 tuna sandwiches, that would be less than or equal to the $30 that you have to spend. 11 chicken and 1 tuna, 12 chicken and 3 tuna, 3 chicken and 15 tuna would all be more than $30 based on the information that they give us here. And that brings us to the end of the lesson on graphing inequalities from 2 variables. So remember, the main points for being able to graph an inequality, you need to write the inequality so that it's in slope-intercept form, because that allows you to find the boundary line. Remember, the boundary splits the graph into two parts. And then what you do once you've got your boundary line, remember, you're going to decide whether it's going to be a solid line or a dotted line. If it's greater than or equal to or less than or equal to, we use a solid line. Greater than or less than, we use a dotted line. Once you've got your boundary line, you take a test point on one side of it to see if it makes it true or false, and decide which half of the plane is the true side, which side is the false side. You shade in the side that gives you all of the true values for the inequality that you're graphing.